Hi maths, this is just for extension people, so advanced maths you don't need to do this because I'm going to be doing just quickly 7.9, which is an extension topic, and it's about the angle between two lines. Now the first thing I'm going to do is prove the formula, then I'm going to tell you the formula and how to use it. Okay, so we want to know what is the angle between these two lines, okay? And we're given the formula of the angle, for example. Not the formula of the angle, the formula for the lines. So we're going to call this theta, which is the angle we're trying to find. Now here is angle alpha, which we can work out is the gradient of this line. We can work out from finding out the gradient of that line. And here is going to be beta, which we can work out from finding the gradient of this line here. Okay, now we can work out from the angle sum of the triangle that alpha plus theta equals beta, or the sum of the external angles. The external angle equals the sum of the two interior angles, that formula. Okay, which means that theta, what we're looking for, equals beta minus alpha. Okay, now here's a bit of interesting proof. If we go tan theta, therefore, is going to equal tan beta minus alpha. Now if we use our formula for the difference of angles in tan, we can go that tan beta minus alpha equals tan beta minus tan alpha over 1 plus tan beta tan alpha. Okay, so that's all agreed there, which is all, of course, equal to tan theta. Equal. Now, tan beta is the gradient of that line. This line's gradient, the gradient here, M2 equals tan beta. The gradient here, M1 equals tan alpha. So let's replace all of these tans with their respective gradients. So that is going to wind up being M2 minus M1 over 1 plus M2 M1. That makes sense. Of course, it doesn't really matter. The order of the m's, the 1 or the 2, doesn't really matter. That is, of course, going to equal tan theta, where theta is the angle we're trying to find. So if we know the gradient of our two lines, we can plug them into this equation here and then do the inverse tan to find out what the angle is here in between our two lines. Now, it's going to only give us an angle between 0 and 90, okay? 0 degrees and 90 degrees. But that means that we're either going to find out this angle or we're going to find out this angle, okay? We're going to find out one of them. Somehow we're going to find out one of them, okay? And then if we want to find out the other one, we just do 180 minus that one, okay? Okay, so this is 180 here minus alpha, minus theta there in that little thing there. So you can find out any of them. Once you find out one, you can find out the other ones. Okay, so the formula you need to remember is very simple. M1 or M2 minus M1 or M2 all over 1 plus M1 M2 equals tan theta, okay? Sometimes they might tell you the angle between the two lines and then you've got to find out the other gradient or something. You know, use your equations just as you always do. So you plug in gradient 1, gradient 2 into those spots, and this is going to be the angle between the lines. Okay? Sometimes you might have to find out what the gradients are first, or whatever, but this is the formula that we need to use. M1 minus M2 over 1 plus M1 M2. And it's easy to remember if you already know this formula down here. If you already know that one's really easy, okay? Simple.